Welcome to my build of a creature from the Crab Nebula. So this is a Share the Scare in the Halloween. So this is a Share the Scare Halloween object. So this is like a pumpkin. And just picture the pumpkin cut like a Pac-Man with big eyes that are LED lights sticking up. And we'll just take that and put some animated claws on it. Let's see, here's a claw. And then we'll put some motorization to it and see how that goes. So first let's start with the electronics. We've got some electronic stuff here. This is a passive infrared sensor. And it's going to go in, it's got some fairly large capacitors sticking up off the back. I want to protect that, so we're going to put this in a case. So let's drop it in a little cover here. And make a box for it. So this connects to a little circuit board here. It just plugs in like this. Now the circuit board takes the output from this passive infrared sensor and turns on this large FET here. There's some circuitry to do some level shifting because the output from this sensor is 3.3 volts, and the only big FET that I had in stock doesn't really turn on until it gets over 4 volts. So I used a few diodes and a resistor to boost the voltage so that it switches between 1.6 volts and 4.3 or 4.4 volts. It also switches on some LEDs, which are on these lights here. I can just turn on the battery and you can see them light up. And the sensor turns on for a variable amount of time. We can adjust the amount of time that it is activated, and we can also adjust the sensitivity of how it senses infrared heat. These two wires are going to turn on the motor, which animates the structure. So that's fairly straightforward. There's some extra LEDs here which will illuminate the interior of the pumpkin or the Pac-Man. These eyeballs, I was going to use ping pong balls, but found these at the dollar store. They're pretty ugly, but that's what you want on Halloween. These tubes here are a straw from Burger King. They make a great Oreo milkshake, and it comes with this fairly robust large straw which I cut in half. You can inhale an Oreo right through that straw, but they make great structural mounts for these eyeballs, which will be sticking up off the crab head. So that's the electronics. The motor looks like this. It's a gear motor with a tiny little motor in it, and we're going to mount this motor. Let's see here. Now we have a crank on top of the motor, which is going to move everything, and we need a little bit of a washer here to prevent the crank from hitting this little axle for one of the gears inside it. But if we snap the crankshaft on it, that's what the motor is going to do. This whole thing takes about 44 different 3D printed parts, and about 20 of them are moved by this motor. They all snap together. There are no screws in this whole build. So this is a motor mount. Fairly complicated shape, which is going to slide into the lower chassis of the device. and the motor just drops into it like this. So now we have the motor, and notice the crank misses the arms of the chassis. But to prevent the motor from coming out, we have a clip here with a couple of little diamonds to go into these little diamonds on the side, and it's pretty tight. And very tough to get on, which is what we want. There we go, snapped on, and it's very tight. This hole is going to lock it in place once we put it on the main chassis. So let's do that. This is the shoulder arrangement for the arms, for the claws. Notice there are 2 axles on it, and they don't move. So this just drops in. Sorry, it comes in from, yeah, it should come in from either the bottom or the top. And it just slides down here to a optimum position, which is where these 2 holes line up. And we put a dowel pin in here to lock the position. Just snaps together like that. So now it can't slide, it's locked in. And this goes into the bottom chassis, which has got the legs. There's a little clip here on the top, which you can see, to catch this thing so that it can't flip up at the back here. And on the front, again, we have dowel pins to lock it in place. If I can find the other one. Okay, here's the other pin. And we'll just snap that in there. So now this whole thing can't slide out. It's locked in place. The motor rotates in the lower chassis. Now let's move on to the arm. So I didn't hook up the motor yet because the terminals on the motor are quite delicate, and I wanted to put a tie wrap on them and steering leave that before, or as soon as I connect them up. So during this assembly phase I want to leave that till last. But let's move on to the arm assembly. So we have claws, which are more parts that are 3D printed, and we have a connecting rod, a connecting arm. So these things have a pivot point and a lever pin. So they go like this, and then because this one is rotating about this pin, this one's also rotating, it needs a slot, so that as this one rotates, the slot is accommodating the rotation. And we have a little clip that holds those things together. This one is tight, and it snaps on. And they can just move like that. And that goes into a big arm. So there's 2 pins here for the claws to rotate. You just snap in there like that, and you can see this moves the claw. And it moves quite freely, so the motor shouldn't have any trouble driving it. Now there is a lid that goes on here, but I'm going to leave that off so that when I fire up the motor you can see how it operates. But let's just put it on the chassis. So here are these 2 axles, And we have to put the slot for the arm into the crank here. So let's move that into place and slide that on. That's how it operates. So when this crank turns, let me see if I can get that all in the frame there. So when the crank turns, you'll notice that the claw goes in and out, the arm rotates as well. And the amazing thing is that neither of these axles is moving at all. If you watch, they don't move. But everything else is moving. And of course we have a second arm which I've completely built up here. So we can move everything with the same motor. So I'll have to fire that up so we can see how that actually operates with the motor running. Now on top of all this, we've got an upper chassis, which is also going to be held down with dowels, and I don't want to plug that on yet because I want you to see the mechanism operating. But there's a battery compartment up here, which is going to take this battery. So let me just show you how it fits. The battery drops in there like this. Now it can slide back and forth, but it's intended to be, up at the front. And there's a little lid that goes in here and slides back. And when I push this down at the back here, it locks it in place, so the battery can no longer move. It's stuck in there really well, and the cables come out in here. In the front here is where I'm going to mount the sensor, the infrared sensor. So let's put the motor on and just see if we can get this thing running. Actually, one thing I forgot to mention was that on the main chassis, I was a little bit worried that the big arms out in front here would tip the device over. So I left a pocket in the back for a counterweight where I can just put a little R2-D2 kind of unit to give it some counterweight there, but it turned out to not be necessary. Okay, I had a bit of a camera failure trying to record the final assembly process, but it's all together now, so let's have a quick look at the motion. So after it warms up, it's sensitive to heat in front of it. I seem to be moving too much. Okay, so I'm a few feet away. Now if I come closer, it immediately detects my presence. And let's turn it off. So the heat sensor is good. It works very well. And the motor's working smoothly. I just have to put the pumpkin on. So let me do that and get back to this video. This just gives some idea of how big the pumpkin is that's going to form the head. I have to carve a big Pac-Man mouth on it and stick in the eyeballs. Alright, I'm trying to get away from that heat sensor, but when I come into the picture, it immediately starts up and we can see the full effect. I left some of the guts of the pumpkin hanging down so we can see some of that. I was thinking maybe to overlay some SpongeBob music. So there we go, all done. I was going to print this in orange. I did buy some orange PLA, but it didn't come in time, so I had already printed everything in white, and I think the idea comes across quite well in white, so that's the way I'm going to leave it. He's waving goodbye.